Hey, everybody, welcome. My name is Roberto Alvarez. I'm a venture partner with Celder Capital. Celder Capital is an early stage venture capital company. We invest, we make seed and early technologies and companies that are active up there, that are taking to the market new solutions for space activities, but also technologies with origin in the space ecosystem, the space industry that are applicable here on Earth. We're here today for our Celder investment series, and I am delighted to have with us Barbara Belvisi. Barbara is joining us from Paris. She is the founder and CEO of Interstellar Labs. Barbara started her career in finance, and today she is building and running Interstellar. Barbara, it's amazing to have you here. Bonjour, not bonjour, but yeah. Thanks for being with us.
Bonjour, Roberto. Thank you. Thank you so much for having me. Very happy to be with you today, and very glad to do this show with you and talk about more about space application on Earth, future investment, all of that.
Well, one good reason to invest in space is that the space economy is growing. We were just talking about that. If we have a look from here to 2040, we expect the economy to grow 3 times. That provides a good reason. But I wanted to learn from you, Barbara. How have you come from finance to space? What's your journey?
It's a it's combination of different things. The first thing is of course, as many of the people who are involved in the space industry, it's kind of a child dream. So I told the story a little bit, but it's when I was young, I was always dreaming of living on other planets. So I was drawing a lot, and I was drawing those cities and a vision of the future that we can live on other planet. I even painted the walls of my room when I was a teenager. So it was not only a child but also a teenager. I painted them full of flowers because I was dreaming of living under domes. So that was something that was very vivid in my memory. I think it's because probably I saw in some magazine, some pictures of Biosphere 2, who started in the 90s, some vision of, Epcot, Walt Disney. I'm a Disney kid. I grew up under a lot of Disney movie, and my parents were involved of the launch of Disneyland in Paris. So I think I was very close to this vision of like spaceship Earth, all of that. And so that was my childhood and what I was growing with. And then, I forgot that. Did business school, work into finance, and for many years, for over 10 years, I helped other entrepreneurs build their startups. And I had a big passion for hardware, because I think at the core of any innovation, you need to have a piece of hardware. And it was at the time where, after the phones, after the computer, we were all looking for the new hardware. So I was investing into hardware companies. And after a certain point of financing other entrepreneurs, I realized, well, I want to do something about this planet. I want to work on food production, water treatment, waste management. And that's how I made the link with space. And I started this reflection about applying space technology back on Earth. Just at the moment, SpaceX proved that they'll be able to reuse their rockets. So when the boosters came back, I made this connection between space exploration and system we need on Earth to fight against climate change and find new solutions.
So this is something else that we have in common. I think my involvement with Celder and space, it comes from my childhood in some way. And I just wrote a piece on the Celder blog that tells a bit of that story, right? From watching Cosmos when I was a child and looking up at the stars, staring at the stars in the countryside down in the south of Brazil. So very interesting, and so you are also a partner with the family in Paris, right? And,
yes, exactly.
I had a friend who had a company there with you guys. So super exciting to have you coming from this more digital space, but having this focus on hardware. I think that one of the things that you are designing and will manufacture biopods, right, to grow food, right? Could you explain what is that? And what's the vision? And what's the business vision for that? What's the business case for Biopods?
Sure. So as a company at Interstellar, our job is to help life become multiplanetary, and so we're not focusing right now. We're not focusing on humans. I mean, but we're mostly focusing on other form of life. First, we start with plants. So what we do, like what's our business. It's just we're designing structure that are deployable, where we're going to control inside all the climatic and atmospheric condition, so we can recreate the perfect environment for life to grow, for plants to grow. And our goal is to do that on Earth, in Leo, solar Earth orbit, on the Moon in future, and Mars, and then the company will be there and keep on expanding in deep space, and will pass on. But that's really the vision of what we want to do. So it's really recreating the structures where we will put life there, and we will carry it. First market is obviously on Earth. This is where right now there are people that are here to buy some hardware, and so on Earth, the application of the technology is that we recreate this microclimate, very optimized and very efficient, so we can grow food and we can grow plants inside. And so we're a new product on the indoor farming markets. A very competitive product in terms of pricing and in terms of solution we're bringing to our customers on Earth, and we sell the Biopods. So you buy a Biopod, we deploy it within a few days. You don't need any foundation. You just need access to power. For the first unit, we're not taking care of power, so you need to give it access to power, and then inside you can grow pretty much anything that you want. So what we've been working on with our team of agronomists is to build the largest catalog of plants and the recipe on how to grow them. So let's say you're in Brazil and you want to recreate a European microclimate because you want to grow, I don't know, a specific species of vegetables or of plants. We can do that. And so we will bring locally what you cannot find in your garden. And that's tremendous application on Earth. And so the business is to sell a Biopod. We sell it at 250K plus a monthly subscription to access the data, the seed, and all the operations, and access to our catalog of species on how to grow them. And that's the business. And that's called a hardware as a platform, and we have competitors, and it's a good business on Earth.
And what are the segments on Earth? I think this is, and for sure we've been working together. This fits really well the thesis that we have on Selder, space technologies with applications on Earth. But what are the use cases that you are seeing on Earth at this time for your Biopods?
Sure. The first type of customers is they're cosmetic and pharmaceuticals company. So because the Biopod is completely sealed and we can play with the light, we play with humidity and everything. So it's like very precise microclimates machine that recreates specific climate machine. So we can grow plants in a very efficient way, so increase the yield, but also we can trigger, because we play with the environmental condition, we can trigger the production of specific molecules. And so we are allowing companies in the pharmaceutical world and cosmetic world to grow plants in a super sustainable way, using less water, consuming less CO2. We take CO2 from the atmosphere, but also have better yield, better quality, and find the right environmental condition to accelerate the production of specific molecule within the plants. So first group is really pharmaceutical and cosmetics, and that was not our first target in the beginning, but it happens to be a huge market, which is growing very, very fast. And with climate change, and also with the ESG and more, and those companies willing to be more sustainable, they're looking for sustainable farming solution, and we are currently the only one available on the market for their need. The second group of customers, they're focusing mostly on food production. So it comes from, it goes from farmers to industrials that want to produce specific food in a specific location. So we also work a lot with Saudi Arabia and the Middle East to bring, for instance, to grow strawberry in a desert And that's just an example. The third type of customers is universities and research centers, and it's towards sustainable agriculture. So they want to study how to grow plants more sustainably. So they use our pods to test, and they help us build actually our database of plants and the recipe to grow those plants. The second application for research center and universities is biodiversity conservation. So we recreate specific climate to grow plants that are endangered. For instance, one of our first pod, we've been focusing on recreating one of the climate of Madagascar. And so we focused a lot of endemic species from Madagascar, and we've been able to grow them in our system. So it's direct, just by thinking on, it's all started by how we're going to live on the moon. So we designed a modular station. We took the first module, which is the plant module, which is the most complicated one. We design it for terrestrial application, and now we have a sustainable solution to grow locally plants. So it's a really perfect example on how space technology and space design can help us figure out a system for better living on Earth.
So I think two things that come to my mind listening to you. One is the coupling geography and crops. So your environments are allowing for that decoupling, right? To take to the desert and cultivate different crops there that were not possible, right? And the other thing is your focus on, let's say, high value crops that can be used in pharma, in perfumes, or things like that. Can people go and get one of your pods today? Where do you stand in terms of deploying the technology, taking it to the market?
Sure. So we actually in production. So we have over 70 demands. We didn't officially open pre-order, though. That said, people registered to pre-order the Biopod. From this group and also industrial, right now we have over 70 demands. We will not be able to deliver this year, but next year. So right now we have secured the supply chain for most of our European customers. For United States, it's going to be later this year. We're manufacturing first unit now. So it's a very, very exciting time for us, for the company. We're a small team. We're 30 people, but the team's growing as well. But so we're manufacturing it. We have very soon, within few weeks, actually, I will be able to share the first videos of the pod mounted here just behind me in the hangar. So it's very very exciting.
Wonderful. And where are you manufacturing those? In Paris?
So we actually, for the European customer, we're manufacturing the membrane in Germany. We have a factory in Brittany, so next to the coast, where we are manufacturing the composite base. So the base is made out of composite, so it's very similar to a boat, if you want to think about it. I mean, it's in between a rocket and a boat in terms of like sealing and recreating a perfectly sealed structure, but it has a kind of a boat shell shape. And so the membrane is made of Germany. It's manufactured in Germany, but we're bringing the manufacturing capabilities to United States at the end of this year, early next year. And then we're sourcing the different components from different suppliers worldwide. We assemble and develop our own system even over here. So mostly next to Paris now. Very soon in Florida and in Texas, we just opened a lab actually at the Kennedy Space Center. As we're working on our first payload to send our first plants also to microgravity.
And so, could you tell us a bit more about the plans in the United States and maybe transition a bit the conversation to the space? Well, how do you see your space roadmap developing in the years to come?
Sure. This year, so first LEO, low Earth orbit. So before going to the moon, this is where we're going to do. So what we're working on, so we work very closely with the teams at NASA that are currently growing plants in the International Space Station. So they use two products. One is called VG, the other one is called APH. So we developed. We've been working on a solution that is somewhere in between those two. So it's the same concept than Biopod. This is what we do at Interstellar. So it's like structure, environmental condition, controlling everything, and helping plants to grow, and automating all the regulation of the environmental condition, humidity, temperature, light, CO2. And so that's what we've been working on. And so first we have a super small payload. Hopefully that will go, up there in around November, December, if everything goes smoothly. Otherwise, it's going to be early next year. But so first, we'll start by sending super small payload in LEO, in the space station, outside the space station. There are different programs that. We have different research program plan. The first one, the first small payload, it's very pretty. It's a very beautiful story. Actually, the first flower that we've been cultivating on Earth in our pod was called. It's from Madagascar. It's a periwinkle, Madagascar periwinkle, and we did it because we were recreating the Madagascar pod to protect endangered species from Madagascar. And it happened that Madagascar periwinkle, which is an endemic species from Madagascar, is used also to treat cancer. And so this plant produces an alkaloid that is called vincristine and vinblastine that you find in the leaves of the plant. And so our first mission to space is actually to send a small payload with this plant inside, which is the first plant we grow on Earth in our system, and that's going to be the first plant we're going to send to space, and to look at how the impact of microgravity, space flight, solar radiation is triggering a reaction within the plane, and we hope and expect, to activate the production of those alkaloids inside the plants. And so you see, that's the beauty of we work with pharmaceutics here. They have this need of this molecule, so they need to grow this plant on Earth. But also space can bring, the advantage of discovering how to trigger this reaction. So this plant will produce more of these alkaloids that are used to treat cancer in chemotherapy. Well, that's a little bit of our space roadmap. Sorry, I did. I wanted to mention this story of the Madagascar periwinkle because I think it's very inspiring. And we're also working on orbital station. Designing the entire system for an orbital station that's going to be planned more for 2026, 2026. And then we have several RFI requests for proposal as well to develop the lunar payload. So a small lunar payload first, and then a deployable payload that is closer to what the biopod looks like. So that's our roadmap. And alongside, we have different contracts with NASA and space private companies to send our system there.
So things are moving, lots of moving pieces. But if you imagine, when would you see a payload on the moon really being operable in some way? What's the timeline, just for people in the audience to have a sense?
To be honest, we actually looked at jumping into a mission end of this year, but it will have been a super small payload. So, less than 5 kilo, and a passive watering system because we cannot put too much of a battery to water the plant. The problematic is with the LED, you need enough light for the plant to grow. So we work on a super small system to be put on the moon. I don't think we're going to make it for the first commercial flights, the first landers this year. We'll see. We're still working on it, but we'll see. But it's very close. Like, it's within 12 months. We'll send our first payload over there. So and same. We always start with small because we need to test the watering system, which is the most complex part. And then we need data on how the plant's reacting. And at the same time, the team is working on the deployable and on a much bigger one. So it's now.
Amazing and beautiful story about Madagascar. The other day, NASA has announced that some NASA scientists have cultivated, let's say, a plant using the the lunar soil, right? Or what would you grow on the moon at first? Just a curiosity.
Okay, two things. I think it's amazing. It's great, and I'm a huge fan of of the scientists. They're really, really, really cool. And that's and also it's an awesome work that they did in successfully growing plants in lunar soil. Though I think the vision for the first years of human settlements will probably still be aeroponics slash hydroponics versus growing on lunar soil. The idea is to, again, it's a bit tricky, the contamination and all of that. So I think it's a very, very promising news. But we should still keep on working on what's going to be the real stuff, what's going to be hydroponics, and the way NASA is already doing it in the space station. But that's amazing news. What will we grow? That's a very good question. I don't know. I don't know. Something that makes sense. My mind is stuck on the periwinkle right now, but
it's lunchtime here in the America, so just interested on the food. Yeah. Barbara,
we can do a lot of berries. I mean, blueberries.
Okay, cool. Blueberries. Notes taken. I'll be back to you in the future. Okay. Barbara, just shifting the gears a bit. Let's talk about the business, right? Building and growing in a startup, a space startup, especially one that has an important hardware component, is different from doing that in a pure digital startup environment.
Yeah.
What are the metrics that you follow to keep track of your progress as a company?
Okay. Well, for the product, I give deadline and then making iteration as fast as possible so we can build it. We're still on the pre mass manufacturing phase, so we're still doing a lot of iteration on the design for manufacturing, even though our suppliers are sourced, but there are still some iteration that we'll need to do for V2, optimization of the boom. So how to optimize the boom. The metrics that I'm following, it's it's more the calendar of the roadmap, and when it's green, yellow, red, when we're all late, when it's moving fast. It's more what I'm checking with, having those deadlines, so giving deadlines to the team so we can move forward. Then on the business side, what we're tracking is obviously the pipeline and the number of customers, how we grow, and where they're coming from, and we're trying to grow them all the time. It's going to be much easier as soon as we have the big pods mounted over there. The key hire, the number of people that are applying to join the company. We have a lot of super cool hire that just happened over the past few weeks. Recruiting more and more people, having a lot of people from SpaceX, Blue, and and other company applying as well, Nanorax and those guys. So that's what I'm keeping, as a seed stage company hardware, where we are not selling actively or mass manufacturing. Those are the metrics, the milestones that I'm tracking.
Cool. If you have joined the session now, I'm Roberto Alvarez with Cellar Capital, and I have here with me Barbara Belvisi, the founder and CEO of Interstellar Labs. We will share with you for sure the link for Interstellar's website. Barbara, continuing to talk about the business you just mentioned, people. France has a tradition in aerospace. You're going to the US, already working with NASA in the US. Where are you sourcing your human resources? Because you need capabilities from space related to space technologies, materials, a lot of automation, and as you said, but also agricultural sciences and data. My understanding is you're trying to bundle all those things, creating the framework, automating, controlling different variables, measuring the crops themselves and learning from the data that you get from that. So where are you sourcing your talent, and how do you manage to integrate all those components in practice across countries?
Sure. So actually, we have, I think, 6, 7 nationalities within the team. So it's a very international team, super talented and very multidisciplinary. So most of our team that is coming so we have a team of agronomists. Our lead agronome actually worked 6 years at a startup specialized in indoor farming. So it's an indoor farm background. The rest of the agronomist team, it's a combination of botanists and plant scientists. We actually hiring much more right now. So most of the agronomist team was coming from Europe. We hiring. We're just gonna push a little bit more offers now, but we're hiring a lot of people in Florida on the plant side right now to grow our plant in space team. Then we have a lot of hardware engineers, so hardware and system engineers. Most of them are coming from space companies. So half of the engineering team comes from SpaceX. We have people from also Dassault, Airbus, CNES, the French Space Agency. Then we have a team dedicated to embedded system and software, combination of different groups as well, coming from small hardware startups, big hardware startup, coming as well from Airbus. So it's that, and then we have a big of course, technician and assembler. They're also coming a lot from SpaceX actually, and on the design side, I'm very lucky to have an awesome CPO. His name is Jim Ronet. He was a previous entrepreneur in 3D printing, so he has a very good knowledge on manufacturing and design for manufacturing. Previously, he worked with the famous architect Jean Nouvel and Franck Guéry, and so he helped on taking crazy ideas and to making it so we can manufacture. And so Jim has this background, which is combining architecture, design, and also the manufacturing. That is transforming, a vision into a real product. So it's a super cool team. I think we're the best team, and I love my people. But they're really awesome. They're really awesome.
That's amazing. So congratulations for that. If you have any questions for Barbara, please share your questions on the chat. We will curate those and post to Barbara. But again, talking about like your roadmap, we talked a bit about the team. You have a very sound pipeline, right? You are pre-operational in some way, starting to take to the market really next year and delivering the first commercial pod, but with strong pipeline of 70 orders, right? Could you describe a bit some of the key challenges that you are facing now, or the key problems that you are solving in relation to the technology? I think that's amazing what you're doing, and I'm sure people in attendance would be delighted to hear about what are the things that you are addressing and how you are solving those challenges.
So most of the challenges for our customers are related to having sustainable way of growing food, how to use less water, to use in situ resources. And this is what we're bringing. We're bringing a solution that is very plug and play. If you look at the markets right now for indoor farm, it's rather you can buy a container farm and it's very plug and play, but it doesn't offer a lot of diversity in terms of the crops you want to grow. But it's a closed system. It's similar to what we do, but it's like a smaller and offer less growing capabilities and less diversity. Then if you want to build a greenhouse, it's pretty much all the time custom products. It's not one solution. And what we're doing with the Biopod is that we're standardizing completely the market of greenhouses and indoor farming by putting one product on the market that is very okay. If you want to grow something, well, you just buy a Biopod. And right now there are like this multitude of like greenhouses and they all they're not standardized. So we're trying to bring a standard to the market, and the standard that is very, very sustainable. And and fully integrated. So it means that it's like a one-stop shop. You go, you buy the Biopod. We have everything from the seeds to the recipe to the software to the automation. It's completely integrated, and that doesn't exist so far on the markets. And I think this is where our customers find us very interesting, because we're not that expensive. I mean, we're actually, right on the market, and we provide a very good, very good integrated solution by having this full stack approach, which is hard for a company, to do the software, the all the components, the design, the manufacturing. But that's definitely the way to go.
We got a few questions from our audience here, Barbara, around the, let's say, the technology itself. One of them, it's about the biopods themselves. How big are those? Could you explain what's the size, what's the volume, the area of those?
Sure. The first, so we're gonna have multiple sizes. The first site that we're working on is the entry, and we call the entry pod, and to enter the market. It's 36 feet long, and 17 feet wide and 17 feet high. So it's kind of like 4 containers stacked together in terms of like growing areas, to give you an order of magnitude. Yeah, that's the size of the and then we're going to do much bigger one, because it's an inflatable technology, so we can actually do Biopods that are the size of a tennis court, and then we can do Biopods that are the size of a football, football, I don't know how you say, land.
Yeah.
Playground, football playground. So that's to give you it. So with the first size, it's pretty much, so it's 55 square meter. I don't know in square feet. It should be 600 square feet on the ground, exactly.
Okay. Yeah, that's, yeah. A follow-up question in relation to that. That's related to resolution, right? You have a biopod. Can you have different micro or nanoclimates inside that and control to what's the resolution of your control system?
Sure. On the light water temperature, we can play a lot to recreate inside the pod different climates. Though what we recommend is to create 1 climate per pod. It's much more efficient, because by creating like it won't be that precise, and we really to optimize, we really recommend, like, I mean, and to be fair, it's going to be really hard for us to do like a desert type of climate on one side of the pod, and on the other side of the pod to do a tropical jungle. Well, get 2 pods.
Yeah.
It's a very good selling, marketing and selling strategy. And to optimize, you get 1 culture, 1 species by pod, and that's how we sell more pods as well.
Okay, great. I hope that has asked your question, Tapiwa. Thanks for being here with us. And the other question that we have is about water treatment and cycling. How do you do that, right? How can you operate in a closed loop?
Sure. So the way the Biopod works, you fill up the tank. So it's like, when we used to have non-electric cars, you used to put oil inside the car. With the Biopod, you put water inside. So you just have access to a tank. You fill up the tank with water, and then you close it. And then you don't need to fill it up for a very long time, depending on the type of plants. But then basically the Biopod will use the water tank that is inside, and then reuse the water. So we have the tank that is integrated with the water capture system, so dehumidifier, exactly the same principle that you find in the space station, attached to a UV disinfection system, different membranes as well to purify the water, and then the water goes back into the aeroponics, and it goes back into the plants. We catch back the water that evapotranspirate through the plants thanks to the dehumidifier, because the Biopod is completely sealed. So we have an airlock, the membrane is inflated, it's 400 Pascal over pressure, so it creates a completely sterile environment. And there are no leakages because we developed a membrane that is very that has very low permeability, vapor permeability. We can capture back the water and reuse it. So we only using like a bit less than 2%, and it's mostly what's going inside the plants.
Okay, wonderful. Thank you. So I think this has answered Colin's question. If you have other questions, please feel free to share those here. So we talked a bit about the technology and some of the possibilities, how you see that. How about the business? How much have you raised? What are the rounds you've been through? What's next in terms of growing the company? I think that when you and I last talked before this session today, it was like probably 2 months ago or something like that. You had 20 people in your team. Now you're up to 30. So growing fast, bringing amazing talent. That requires capital. It's great that you have a solid pipeline. But how you see like the business growing? What are the rounds you've been through? What's next for Interstellar Labs?
Sure. So the company, I started in September 2018. First round was around 1.2 million. And then we raised another round. Total was 5, so it's 3 million on a safe note. And then we added, on top of that, investment from the public investment fund, the French one, to finance some of the R&D that we've been developing here. So it's 1.2 and 5. We're actually doing an extension to the safe because we, after the announcement and some strategic hires that we just did, and a lot of very good folks are coming from space industry. So we're doing an extension this summer, and then we're gonna raise a 20 million round at the end of this year to accelerate and to move into mass manufacturing, and to deploy our system and to deploy our assembly line in the US. So that's in terms of investment. It's a we were talking just before the call that there is a slowdown, and for us it's been so far so good, and actually we have an acceleration in terms of onboarding more and more investors. So that's good for us. And in terms of the business, we have 70 demands. The deal is really to secure all the orders, and to manufacture and to deliver the product to our customers next year. What we're planning, what we want to achieve is by the end of 2023, being able to reach a level of manufacturing where we can manufacture 2 biopod a week. So it's like around 100 biopod a year. So it's not like super fast, but it's already a good ramp up because it's a big product. It's and it's never been done before. So that's a pretty cool target, and well, that's a lot of revenue as well. 100 biopods. So that's a good start for next year, I think.
That's amazing. What do you need at this point? So if people in the audience, they are potential clients, potential partners, potential investors, what do you need at this point?
We're recruiting. So we are interviewing great people. So, okay, I'm looking for, I'm going to be very straight to the point, someone who's an expert in working on, the manufacturing and mass manufacturing. So ideally who has a background, it's whether on car manufacturing, or rocket as well. And so to help up scale up and ramp up the production, to work with our team so we can set that up. 10-15 years experience minimum. And then we're also hiring a lot of aerospace engineer, as we have a lot of demand on small payloads and small systems to grow plants. So actually need to really grow our team to work on small CubeSat and small payloads. So our experience on this is highly appreciated. Well, we also hiring more management position now that the team's growing. So we moved from 20 to 30, like in a very short period of time. We're going to double the team before the end of this year. So we're going to put a little bit more of managerial structure as well. So we can scale. We can have the structure in place to scale. That's what I need right now.
That's amazing, and I think I fully understand your challenge to scale up production, and I think that there are at least two key components there. One is your production itself, and the other thing that in parallel to that, as you said, you are creating industry standards, right? You are designing infrastructures and standards that are not in place today. So the two things go hand in hand. Well, one of the questions that we got from the audience, it's about IP. So what's your IP strategy? Do you hold that? Do you have patents? Where are those? Are those like trade secrets? What could you comment about your IP?
Sure. There are some systems that we have patent on, like the membrane, for instance, is provisional a provisional patent. We will, so everything in terms of IP, the whole concept of the biopod and the integration of the different system. This is something that we own. Then we're figuring out from some of those thing that we develop, if we keep it like this, or if we patent as well. There is like a real strategy to have around that, because a patent might not be the best solution to protect yourself sometimes. So that's what we're working on. We are working on with our lawyers now. Of course, trademark, very important. But yeah, IP is key. We develop a lot of things ourselves. We're going to integrate more and more hardware development. For instance, the CO2 scrubber is going to be completely integrated and developed by our team. So same for the HVAC system, having like a fully our own system designing. And so eventually that also can be potential spin-off in the future. But there's going to be more and more integration of the time. Right now, to move super fast and to be able to get a product that is ready for the market as soon as possible, we made some trade-off, and we worked with existing components. There are some components that we want to develop ourselves to reduce the cost of production and to be able to actually manufacture and not to be too dependent on suppliers. That's
That's cool. And when we talk manufacturing, just maybe we could transition a bit to Cellar Capital and how we got connected. We would love to hear your perspective. But also, we have 10 portfolio companies today. We're proud to have Interstellar Labs as one of our stars in our portfolio. We have a company that has developed Fusiomatic new tools that could potentially be used in your solution, and that we hope will be used in construction, in space in the future. We have Acor, who's reducing the risk of biofilm, including in the International Space Station. There are applications there. Maybe it's something that could also be applicable. So one of the things that we try to do is maybe to identify some synergies within our portfolio companies. But commenting on that, what I want to do is maybe turn to you and just how did we get connected, and what would you advise for space entrepreneurs in terms of engaging with VCs, raising fund, and finding opportunities to build and grow their companies?
Sure. I think I heard from different groups actually about Cellar Capital, and Sydney had a very, very good reputation, as a investor and someone who's really passionate about space and someone who's there to really help entrepreneur. And entrepreneur, we talk. So the truth is that we talk about investors. We could talk about good people. Investors talk as well. So I like to make connections. So I think we were connected. I know we had a very good contact with Sydney, who's Tej Paul, who's actually the chief commercial officer at Axiom Space, and also through Adeo Rissi, who's a very dear friend of mine, and who actually was very who helped me from the first day, putting this company up, and introduced me to a lot of people at SpaceX and NASA. And Adeo was same awesome feedback about you guys and the vision that you had with the fund, where you wanted to go, and the fact that you were also looking into space technology that have terrestrial application. And so far, I mean, you've been, and I know it's going to continue, but you've been super helpful And I don't know if there are entrepreneurs, watching today, but Seldar is really an awesome fund, and they connect you with their portfolio company and with potential other investors. They understand the business, they understand the space business, the terrestrial application of it. Really cool, really really cool. So thumb up
Thank
for
you.
you.
Thank you. It's great to hear that. I think that, and Sydney was just reminding me, dear Rossi, who's also an advisor to Seller Capital, right? Is
Yeah,
like
yeah,
who has introduced the Interstellar opportunity with me. Delighted and very, very happy to work with you, Barbara.
yeah.
For colleagues in the audience, if you have any other questions, feel free to do it. And Barbara, back to the investment, maybe a bit of what we just talked about, your connection and experience with Seldar, but looking at the broader investment landscape related to space, what are the things that you see flourishing, and what would you say to space entrepreneurs wannabe, folks who wanted to get into the space economy?
Um, I think it's a good time to think about, of course, we've seen a lot around rocket propulsion. There is still a lot of innovation that needs to be done in propulsion. So I think it's still an area where it's a good thing to be an entrepreneur. It's very very competitive. So though you need to have a very very good team, and here I think it's a question also of team and experiment. Right now, the competition among the propulsion, but there are still opportunities. The second one will be on the space exploration, deep space exploration. I think this is where we need to push a little bit more, and not being only focusing on the vehicle, on how to get there, but to focus also on what's going to be life when we're out there. What does it mean to build a sustainable city on Mars? What does it mean to build a sustainable moon base on the moon? I mean, this is what we are working on, but there are tons of things. There is the habitat section, all the life support. It's pretty broad as well. So those areas are super interesting. And we will need a lot of people, if we want to build a sustainable city on Mars. So I would recommend to go there to focus a little bit more on deep space exploration. And yeah, I mean, it's pretty crowded right now when it comes to CubeSat and payloads. So I will focus more on services and application and space businesses. There are like 7 orbital stations right now that are in construction. So I will focus more into, okay, how do you bring business, and how do you leverage those platforms to build your own business? So leveraging on top of what others are building, I think, is the way to go right now for space exploration. Yeah.
So broaden the view. That's where I take for you, not just to have a look at the whole spectrum. You mentioned the different space station projects. There are more than 100 missions is slated to go to the moon in the next decade. So that's a lot. So have a look at the broad spectrum. We got a few other questions here from our audience, that some of them are related to the technology, some of them are related to the business. So one thing here, it's what's your balance between outsourcing and using in-house capabilities in this full stack approach that you need from agricultural sciences to automation control technology? How are you managing that, especially in a time of fierce competition for talent?
Okay. Alors, the company is still young, so we don't have we can integrate as much as we can. But the vision is of course to leverage on existing technology, but there is not that much that you can do after. So integrating existing technologies is a very fast way. so you can develop your product and you can go to market quickly. But if you want to move into mass production and cost optimization, then you need to integrate a lot of the manufacturing capabilities. So next year, we're going to integrate the manufacturing of the membrane, probably the manufacturing of the composite as well, the development of the CO2 scrubber. And so for that, you need to hire people. And as you said, there is a competition for talent. Well, so far, we've been pretty lucky. We've been attracting a lot of people. I think the project has a big vision, and so that's why people are coming and willing to jump on board. Though it's a competitive market, so we will need to raise more to also, offer our team, good salaries and keep on growing and growing. But I think the project has a big vision, so that's why it's appealing to a lot of people. But so I'm more of a person who, especially when it comes to cost optimization, because this is where, when you make hardware, you want to make enough margin for a company to be sustainable, so you don't keep on fundraising all the time. So you need to integrate part of your supply chain and manufacturing. So this is the way to go. And same right now, we're using a lot of small GPUs and small microcontrollers to automate our system. Well, at a certain point, we will need to develop our own embedded system and our own, and our own controller. So there's step by step. You do the different. You try to be smart in the scaling process, using off-shelf technology and then replacing them by integrating. And you do that over time with the fundraising and the team that is coming over. The more we raise, the faster we will be at integrating the key areas that are making sense for us.
Yeah. And again, back to your journey, Barbara, and I think I very much paid attention to what you said about the metrics that you are following and how you are seeing the whole development and manufacturing process and the need for speed in that. Actually, I think this is an approach that companies like SpaceX have really brought to the arena, a different way of iterating in the hardware space, and you are following that. What have you learned in the process of fast iterating, not just about your technology, but about the whole process of developing a space startup?
Okay. So I think there is something that is interesting about us is the space and the terrestrial aspect. For the terrestrial product, we did some quick prototypes and to validate some key principle. And you want to make it using cheap system and move fast because you just want to validate. You want to get your MVP and your proof of concept and then your MVP. But we made something like if you look at the terrestrial biopods, then we move straight away from beautiful design and finding a way to manufacture this. And so it means if you and then I'm gonna go to the space. But so we got away from like the scrappy super fast iteration, and we've been focusing on making something that has a very beautiful design for terrestrial application because we wanted to go very quickly to the market and to get the customer attention. And so the choice was made to go for a product that where design was super important because we wanted to differentiate ourselves also from the customers. And so for this one, for quick iteration, well, it's complicated, to quickly iterate when you do a cell design and you need to do it. So the quick iteration was on the proof of concept and MVP. Now we're building it, and then we'll see, how we're going to change a different system. But that's very different from when you need to. But you can do that when the technology is proven, and so you don't need to quickly iterate. You need to optimize, and so that's a different things. The quick iteration in manufacturing. that's my understanding of what's happening, at Starbase and what SpaceX doing. Like, how they completely changed the way of manufacturing rockets. They need to manufacture very quick because they need to do a lot of testing. So you need fast iteration on the model, the system. They're gonna, blowing rockets and everything. So you don't want to invest too much money into making a mold to do like a nice, sleek, composite, beautiful rocket that's gonna blow, and you're gonna lose tons of money. And so for me, you do quick iteration, like a little bit of like, scrappy and like metal and super, super fast. So you don't really focus on this, I love the design of Starship, but that's not the focus. The focus is like to build fast and to test and to iterate, and yeah, and that's what we learn is it's two different things. When you want to test technology, you not focus too much on the design, but you build fast and you iterate. When you have a technology to prove and to some R&D to do, when you want to move to market, I think design is key and needs to be integrated straight away in the design for manufacturing process, because otherwise you need to redo it completely.
Great learners. So we are approaching the end of our sessions. We have 5 minutes to go. This is your last chance to ask a question, so please do it. And Barbara, what else would you like to share here with our audience in terms of your company, your future, opportunities related to space, places where you want to go in the globe and connect and have your solution deployed? Any comments from you?
Well, I mean, we want to put the pods everywhere. So, feel free to reach out if you're interested in getting a pod. Of course, we're growing the team in the US. So we have the new office at Kennedy Space Center. We're opening also another place in Houston to be very close to, people that are working on orbital stations. So yeah, that's the focus. We're growing the team. I think the main purpose of our company is really to help spread life anywhere, and so we can bring nature with us in our journey into the stars. This is what the company is about. And yeah, I think we have an awesome team, beautiful mission, good business on Earth, super promising business in space, and the future of agriculture in space and plant growth and manufacturing in space is just it's going to be really, really big. So yeah, help us join our journey, apply, invest, buy a biopod, get a payload, finance your payload. We can bring your favorite plants and and build a constellation of CubeSat around the Earth. I'm making jokes, but yeah.
Yeah. So you are having 2 locations in the US to connect with let's say people working on space stations and NASA. Will any of those do some manufacturing too? How's the team in the US at this point? How big is the US operation? Just if you could comment about your plans in this side of the Atlantic.
Sure. Well, we're gonna leave 2 biopods here this summer, and then this fall we're gonna bring 3 biopods in the US, 1 in California, 1 in Texas, and 1 in Florida. To be completely transparent, we're still figuring out where we put the assembly line and the manufacturing capabilities, and it's gonna be Texas or Florida. And with Florida, our main focus is really on plant science and collaborating with the plant team at NASA KSC. We've been very close also to rockets. So as we're manufacturing our payloads, we can have direct discussion with the several teams. For the terrestrial products, but we'll see if we put that in Florida or if we put that in Texas. Texas making a lot of sense for us to manufacture the biopods for terrestrial applications. So we'll see how we split, but that's the plan.
Promising news on all sides of the Atlantic and in other places, and not just here on Earth, but in space. Barbara, it was a pleasure to talk with you. I hope you who are joining us today have enjoyed the conversation. This is one of our Cellar investment series. We're having conversations with the founders of our portfolio companies. Please check that out. Please stay tuned. We'll have a new session coming up next week. And you can also go to Seller Capital's YouTube channel to check our previous sessions. Barbara, again, it was a privilege to have you here. It has been a privilege to work with you. Thank you so much.
Thank you, Roberto. Thank you so much.